In this nutshell, you will practice your programming techniques. You will write the code for a transmitter and receiver for a remote-like control, and you will base this from a state diagram. And if you do find this video useful, please like and subscribe. You are to write the C code for the remote-like controller transmitter. It's one we've done before, but in this case we want to do pseudocode and a state diagram. So the light controller sends commands to a light unit, instructing the light unit to turn the light on or off. The controller communicates with the light unit via Bluetooth using the USART 2 serial port. If the on button is pushed, the controller transmits the character A. If the off button is pushed, the controller transmits the character D. Now we do have a different serial format. We're doing even parity, 8 data bits, 2 stop bits, and 57.6K baud rate. And these are our inputs and outputs. So pause the video and try to write the pseudocode and the state diagram. So this is the pseudocode that I wrote. I have 3 states: idle, send on command, and send off command. This is the state diagram shown here. We start in the idle state. If the on button is pushed, we go to the send on command state, and there we transmit the command A, then we return back to the idle state. If the off button is pushed, we go to the send off command. We then transmit D and return back to the idle state. So now pause the video and write the C code from the state diagram. This is the code derived from the state diagram. Firstly, we have our defines. We are looking at the transmit data empty register. We're looking at pin H4 for the button on and pin H7 for the button off, and we have our state constants here. We create our state variable, we have setup, and then we use a switch statement shown here for the states. We have case state idle in that condition here. If the light on button is pushed, we change to state transmit on command. If the light off button is pushed, we change to state transmit off command. So in this state transmit on, we wait for the transmit buffer to become empty. We load A into the data register and we go back to the idle state. In this case, state transmit off command, we wait for the transmit buffer to become empty. We load D into the data register and we go back to the idle state. So this switch statement here is showing the state diagram. Looking at the registers for the USART, the first one looking at is the data register empty flag. That is shown here, UDRe, and the N is 2 for USART 2. It's actually bit 5, so you could replace that with 5 if you wanted to. However, Microchip Studio has defined that as 5 for you, just to make your code more clearer. Looking at the registers we are setting up, the first one is the baud rate register. We can use the tables for this. So we have an 8 MHz crystal. We're doing 57.6K, so therefore 8 is the value that we're putting into the register. And because this is less than 255 decimal, we can load that directly into the lower register. Looking at the USART status control and status register B, we can see that these 3 bits here, bit 7, 6 and 5, are the interrupts. We're not using them, so they're 0. We're not using the receiver, so that's 0. We're pairing on the transmitter, so bit 3 will be a 1, and these are all 0. And finally, looking at the controller and status register C, this is the register shown here. Bit 7 and 6 sets up the mode. They should be 0, 0 for asynchronous, so they are 0, 0 there. The next two bits are for the parity, bit 5 and 4. We are doing even parity, so that should be 1, 0. 1, 0 as shown there. We are doing 2 stop bits, so that is shown here in bit 3, so that should be a 1. So we can see that's a 1 there. And finally we're doing 8 data bits, so therefore these bits here, 2 and 1, and they should be set to 1, 1 as shown there. And finally the clock polarities are only used in synchronous mode, so we can ignore that and leave that as 0. And lastly, the actual USART 2 transmitter goes out port H1, so I set that for an output. Now looking at the light unit, that switches the light on or off depending on what command it receives. We look at the unit and we say that if the unit receives a character A, it should turn the light on. If the unit receives a character D, it should turn the light off. Same serial format as we had before, even, 8 data bits, 2 stop bits, baud rate 57.6K, and our inputs and outputs, we have the receiver on USART 2, and the light is on port B, bit 6. So pause the video and write the pseudo code and the state diagram for this problem. There are a few state diagrams you could derive from that problem depending on your imagination. I'm showing 3 here. The first one is idle. If new data is received, we go to the control light state. If the received data is A, turn the light on. If the received data is D, turn the light off, and then return back to the idle. That's showing that pseudo code here. Alternatively, you could have 3 states. In idle, you look at the data. When you receive the data, you look at it. If the data is light on, turn the light on, then go back to the idle state. Alternatively, you receive the data. If the data is light off, go to turn the light off state and go back to the idle. Or we can have 4 states. In the idle state, if we receive the new data, we go into the state check data. If the data was light on, then we turn the light on, go back to idle. If the data was light off, we go to the turn off light state, back to idle. And finally, when we check the data, if the data was incorrect, we go back to the idle state. So let's try and program the more simpler one shown here. So pause the video and write the C code from this state diagram. This is the code I have written from the state diagram. Looking at the code, we look at the defines. We are looking at the receive complete flag in UCSRnA to see if data has arrived. We control the light using port B, bit 6, and then we have 2 state constants, state idle and state control. We have a main, we have received data that's used to store the received data, and we have a state variable here that we initialize with state idle. Now just going over the switch statement, which is used for the state machine. We repeatedly go into the switch statement, and depending on what value state is will depend on what case we do. So if state is state idle, we will do this case and break. If the state was equal to state control, we will do this case and break. If we are in the state idle, if we receive new data, then we store that and we go to state control, as shown here. If we are in state control, if the received data was A, we turn the light on. If the received data was D, we turn the light off, and then we go back to the idle state. So that's how that switch is representing the state machine. Looking at the register setup, first off we'll look at receive buffer full. So that's looking at the USART control and status register A, and we are looking at bit 7, which is the receive complete. That means it's received new data. The baud rate doesn't change from the transmitter, nor does the control register C, which configures the mode of operation. But there is a change with 2B, the difference being we are powering on the receiver, so bit 4 is a 1, we can see here, and the transmitter is not being used, so bit 3 will be a 0 as shown there. And finally, the light is on port B bit 6, so we set the data direction register for an output for that bit, and we initialize with the light off. One feature of the megaPro board is that we have a digital switch that will switch the output of the transmitter back into the input of the receiver of the USART. So if we transmit anything out, it will come back into the receiver. So looking at that, I have got both the remote transmit code and the light unit receive code combined together. So we have two separate state machines shown here. We had the flags for receive buffer full, transmit buffer empty. We had the bit masking for light on and light off button. We had the light on, light off control. We actually use port C to display the hex value of the data received. And then we have our state machine variables or constants shown here for both the state transmit and the state idle state machines. Coming down into the main, we actually have the transmit state set to idle, receive state set to idle as well. In the state machine for the transmit code, if the light on button is pushed or light off button is pushed, we go to our different state machines and transmit A or D. In the receive code, if the receive buffer is full, we store the data. We actually also output that stored data to the hex display, and then we control the light on and light off. The only difference really in the setup between these two things is that we have turned on both the transmitter and the receiver for the USART. So I have written that in Microchip Studio, and we can download that to the board, and then we can see that running. So this is the on button on the transmitter. If I push the on button, the receiver has received A, which is 41, and it's turned on the LED. On the transmitter, if I push the off button, then we've received D, which is 44, and the light has gone off. So we can see the receiver and transmitter working together.